Hello, welcome to Math with Beth, and we are going to be doing antiderivatives as areas. So we're going to find antiderivatives and let them help us find the area under certain shapes. So at first, we're going to be doing it with shapes that we can just look at and find the area using the graph because they're going to turn into rectangles or triangles. But then we're going to see how do we do it if we have a curved graph, which would make it impossible for us to just calculate the area using geometry. So for number one, this is basically saying, can you find the area under the graph y equals 8, but only looking from 0 to 2? So these are kind of your interval that you're looking at. So these are the x's. So first, the graph y equals 8 is just a horizontal line at 8. But if we're only looking from 0 to 2, do you see that that cuts it off here and makes it a rectangle? So to find the area of that rectangle, we just need to remember basic geometry. If this is 2 and this is 8, our area is going to be 2 times 8. That's it. So anytime you have a rectangle, you should be able to just do it with basic geometry. Example 2. Now I have to think about the graph y equals x. So that is a line that goes through the origin, up 1 over 1, up 1 over 1, up 1 over 1. And I'm looking from 0 to 3. So this time we've made a triangle. The base of the triangle is obviously 3 because I went from 0 to 3. But here I have to think, if my x is 3 here, how high would I be if I'm in the equation y equals x? Well, you can just plug in 3 to find out. So if my equation is y equals x and I'm plugging in 3, obviously it is also 3. So now we just need to remember that for a triangle, the formula is 1/2 base times height. So in this case, 1/2, 3 times 3, or 9/2. That would be the area of that triangle. Okay, so now what if we have something that's a little more complicated? So this is still going to be a straight line, so that's good. But I'm looking at between 0 and 10. This is a line that would start at 1 and go up 5 over 1. Up 5 over 1. So basically, it's going to have a really sharp curve there. So if I'm looking at what happens when it's 10, it's going to be way up here. So maybe I should redraw that. Let me redraw that down here and go by 2's maybe. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So if I'm starting at 1 and going up 5 over 1, it's going to be something like this. And we're stopping it at 10. Okay, so it looks like a triangle, but it's technically not because of this little tiny part here. So this is really a trapezoid because it goes up 1, then it has this curve. So first of all, trapezoid, the formula for area of a trapezoid is 1/2 height B1 plus B2. So does everyone see that this little tiny part here makes it a trapezoid? So I need to think about the height of this trapezoid, which is not this, because you need to think about where the top and bottom are that are parallel to each other. So really, this is my base 1, which is just 1. This is my base 2, which I need to find by plugging in 10 to the equation to see how high it is. So if I plug in 10 to here, I get 51. So this part is 51. and then this is actually the height. So remember that was 10. So area equals 1/2. My height is actually 10. My base 1 plus base 2 would be 1 plus 51. So if you did all of that, you would end up getting 260. So the reason that one was so much harder is because it became a trapezoid. So you just have to be really careful with your drawings to make sure you know what shape you have. Okay, so now what happens when we have a curve? Using rectangles to find the area of curves. So if there is a more complicated equation and it ends up being some kind of curve, unless we could make it a perfect circle, what we're going to do is we're going to split the section into multiple rectangles to try to get as close as we can to the shape of that curve. So the first one they want us to try is x squared plus 1 over the interval 0 to 5. And they're going to tell me how many rectangles they want me to split it into. So 5. So here's my setup. I'm going from 0 to 5. The equation, x squared plus 1, I could use a graphing calculator or Desmos, but I know that that's just a parabola that starts up 1. So it's going to look something like that, but we're cutting it off at 5. So this is the shape I'm trying to find, but they specifically want me to split it into 5 rectangles. So starting from the left, if I make this first spot a rectangle, it would look like that. Then that. So you can already tell that I'm under the correct answer because you see there's a little bit that's obviously missing as I go. So this answer is going to be a little less than the actual answer, but it's as close as I can get if I'm splitting it into 5 rectangles. So each rectangle is going to have a width of 1 because if we went from 0 to 5 and split it into 5 sections, each one would be 1, but its height is going to be different each time, and it depends on what I get when I plug in 0 into the equation. That would give me a 1. Now I need to plug 1 into the equation. So 1 times what I get when I plug in each number into the equation to get the height. So if I plug 0 in, I would get 1. So the height of this first rectangle is 1. But now I need to plug 1 into the problem. 1 squared plus 1 would give me 2. So the height of the second rectangle must be 2. Now I'm plugging in 2 into the equation to see the height of this third rectangle. 2 squared plus 1 is 5. Now I need to plug in 3. 3 squared plus 1 is 10. And finally, for this last rectangle, do you see that it's 4 that I would need to plug in? Because that's what gives me the height. So 4 squared plus 1 is 17. So since all of the widths were the same, do you get that I could have just kept that one out front and just worried about the heights? The height of the first one plus the height of the second one. So either way would work fine, but this way will be a little easier when these get more complicated, that you'll understand you can just put the width of each rectangle out front and then just worry about adding up all of the heights. So if we did this correctly, we would get 35. And we know that's not the exact area because there's obviously some that was missing. Now it's going to ask me to do the same thing, but with 10 equal size subintervals. So I'm still going from 0 to 5. I still have the same shape because we're still using the same equation. The only difference is they want 10 rectangles. So starting from the beginning, that's going to make me just go to 0.5 each time. Still ends up being under the exact answer because you see sometimes I'm not going quite to the top. But definitely seems like I'm getting closer. So obviously, the more rectangles you split it into, the closer you're going to get to the exact answer. So let's do this one the easier way where we say, all right, we know the width of every single one is going to be 0.5. So now let's just find the height of each one. So we're going to plug in 0 into the equation again, which still gives us 1. But then we need to plug 0.5 in, then 1, then 1.5, then 2, then 2.5. So that's what I'm going to do now. Plug in all of those values. So this is plugging in 0. This is plugging in 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, and 4.5. So I'm going to add all of that up and then multiply it by 0.5. So this is me adding all of the heights. And instead of multiplying each height by the width each time, I'm just going to add all of them together and then multiply them all by the height or by the width one time. Okay, adding all that up, I get 81.25. That times 0.5 is 40.625. So which answer is probably closer to the actual area? This one. What would get me even closer? Making even more rectangles. So the more rectangles you have, the closer you are to the correct answer. Both of these answers, though, would obviously be a little under the exact answer because the rectangles ended up not quite getting to the top of each one. Does that mean we will always be under? No, because if this problem had been going down and we wanted to start at 0 and make rectangles, do you see that in this case, the rectangles would end up being a little above the curve? So sometimes using rectangles will give you an answer that is a little under the exact answer, and sometimes using the rectangles will get you an answer that is a little above the exact answer. It depends on which way the curve is going. So hopefully that's enough for you to give these a try and let me know if you have any extra questions once you try some of this.